This is the second video in the progression for Chapter 5. Once again, just watch what you want to watch for the things that you have questions on in order to best prepare for the final. For standard form, we're going to write this in decreasing order of their degree, or in other words, the exponent attached to each term. So these two are like terms, so with the biggest exponent, so those will go first. So 6 minus 2x to the fifth is 4x to the fifth, minus 2x squared plus 1. So this would be a quintic trinomial. The first word we use is based off of the degree. The second word we use is based off of the number of terms. Number 2. The largest degree is 6x cubed, or the 3. So we get 6x cubed. Then we look for the x squared, so we only have 1, so we have plus x squared. The x's, we're going to go ahead and combine both those to get negative 8x. And then we have plus 1. So here, because this is 4 terms, it's just a polynomial. Once we get more than 3 terms, we call it a polynomial. And then the first term has a degree of 3, so it is a cubic polynomial. Okay, so the end behavior is based off of a couple things. It's based off of the degree and then the sign of the leading coefficient. So if the sign's positive or negative, and if the degree is even or odd. If it's positive and even, we get something that looks like a parabola. So we would say up and up. If it's even and negative, we would get something that would be like a downward parabola. So we would get down and down. If it's positive and odd, we get down and up, and odd and negative, we get up and down because it flips it over the x-axis. So in this case, we just look at that leading coefficient, which is wherever our degree is attached to. And then I just wrote over it, so there we go. So this one is positive, and it's even because of the positive in front of the 2x squared, and the squared is an even exponent. So in this case, it is up and up. This one is also positive, but it's odd. So this one would be down and up. And you can always look at it in your calculator too and just say where the arrows are going. Just make sure you read it left to right. Okay, this one, the zeros shouldn't be too bad. Remember, whenever we're looking for the zeros, we just literally set it equal to 0. So we set the two factors equal to 0. So here are two factors, x equals negative 2 and x equals 3. Their multiplicity is the exponent that's attached to each one. So the multiplicity of this guy is 1, and the multiplicity of this guy is 2. So this is going to cross the x-axis because it's an odd multiplicity, and this will touch the x-axis because it's an even multiplicity. This one, we can't get the zeros until we have it in factored form. So notice number 5 is in factored form. So here we set it equal to 0, and in order to factor it, the first step is to always look for a GCF. The GCF of this one is x squared, so I take out an x squared, and I'm left with x plus 4. Now it's factored, so we have two zeros, set them both equal to 0. When I set that equal to 0, we get x equals 0 with a multiplicity of 2, so that's going to touch the x-axis. And then this factor has a 0 at negative 4 with a multiplicity of 1 because the exponent attached is 1. Just make sure that you factor first in order to get the multiplicity. Okay, synthetic division is the next one. So for synthetic division, we're going to go ahead and this is the quicker way to divide. We could use long division as well, but for both these, I'm going to use synthetic division because there's just an x out front. So this is 1x, the first power, which is when synthetic division applies. So negative 4 is the number that goes in the box because that's what this guy's 0 or x-intercept would be. So the opposite, or if you were to solve that for 0. Then we line up the coefficients. The coefficient of x squared is 1, then 6, then 24. So we'll draw a little line under it. You drop the first number, you multiply to the number in the box, and then you add the columns. So 6 and negative 4 give you 2. multiply to the number in the box, we get negative 8, add, we get 16. So in this case, we have x squared. It was, excuse me, it's not x squared. It was an x squared, but we're dividing by x. So when you take an x away, it is now just a plain old x. So x plus 2 with a remainder of 16, or in other words, x plus 2 plus 16 over x plus 4. The alternative approach, just so you guys can see it, is if we were to use long division. I'm going to go ahead and erase that and then do the same thing using long division, just so you guys can see both. I like synthetic division because it's quicker though, so if you can use it, I usually do. Okay, so first thing we do is we set it up. We put the x plus 4 on the outside, the x squared plus 6x plus 24 on the inside, and we ask ourselves, we divide the first two terms. What do you multiply x by to get x squared, or what is x squared divided by x? And that is x. So we divide and then we multiply. We take that x and we multiply it to the numbers outside. So x times x is x squared. X times 4, we have to distribute it to both, is 4x. Then we subtract. So when we subtract, these go away. 6x minus 4x is 2x plus 24. Then we ask ourselves, what do we multiply x by to get 2x? And that would be 2. Then we multiply. So we get 2x plus 8. And then we subtract. Those cancel and we get 16. So there's your remainder of 16 again. Okay, so synthetic division over here on the right for number 8. Put the negative 1 in the box because that's what the x-intercept would be. And then line up your coefficients. So 1x cubed, 2x squared, 4x, and 10. These are in order of decreasing degree, so we're good there. Just remember that it has to be in standard form. And let's say that this term were gone maybe, then this would have to be a 0. So this would be a 0 right here. But that's not the case, so let's make sure we change it back, just as a little reminder there for you. So this is a 2. Drop your first number, multiply, add, multiply, add, multiply to the number in the box, add. So we get x squared this time because it was an x cubed, but we took out an x. So we get x squared plus x plus 3 with a remainder of 7. Number 9 says, write a polynomial function in standard form with the given zeros. So our function, if we know the zeros, we're going to start, we have to put them in factored form. So x plus 1, x minus 2, x minus 6. And then at this point, we're just going to multiply it out. So I start by foiling the first two. So the first, you get x squared minus 2x plus x minus 2. And then we still have to multiply that by this last one, x minus 6. So we get x squared minus x minus 2, and then x minus 6 when we simplify that first set of parentheses. Now this is where a lot of people have a tough time. The second one, when we multiply, I'm going to take x and multiply by all of these. I'm going to use the same original polynomial, not my new one, and I'm going to multiply them all by negative 6. So x cubed minus x squared minus 2x, and then negative 6 times all of them. So negative 6x squared minus, plus 6x, because a negative 6 and a negative x, and then plus 12. Last thing we're going to do is combine our like terms. So x cubed, that takes care of that one. Our x squared, so we have negative 1 and negative 6, so that gives us negative 7x squared. Combine these, we get plus 4x. And then our last one, we have 12. So now this is the polynomial in standard form. This original one was the polynomial in factored form. So this is our final answer. Okay, next we're going to write the cubic function that's obtained from the parent function x cubed. So we're just going to show what transformations would look like to x cubed if these things were to happen. So first thing is the vertical stretch. So that means that we're going to have a 3 out front. It's going to be a reflection over the y-axis. So if it's a reflection over the y-axis, that's actually going to go in with the x. So negative x cubed, and then plus 4 because it's a vertical translation, or up 4. So that's what a reflection over the y-axis would look like. We don't do a ton of those. Usually we do the x-axis, so the reflection usually goes in front of the parentheses, or in front of everything, rather than inside the parentheses. If you were to simplify this though, a negative cubed, a negative times a negative times a negative is a negative, so we could simplify this to negative 3x cubed plus 4. All right, the next one's a reflection over the x-axis. So that means that here our negative would go out front. Since it's going 2 to the left, that's going to go in the parentheses. So x plus 2 cubed, and then down 6, so minus 6. And we don't have to simplify that one, otherwise we wouldn't see the transformations. So that wraps up Chapter 5. If you have questions on Chapter 6, go to the next video.